After the coil groups have been dried and upended, they're next loaded into what we call the lower tank of the transformer, and they're in a vertical orientation where we can begin the core stacking process. The core is actually the magnetic circuit of the transformer that induces the current in the secondary winding to allow the voltage and current transformation. Our particular design of transformer we manufacture is called a shell form transformer. The way it gets its name is that the core actually passes through the center of the winding, but also around the perimeter or the sides of the winding. So we say the core forms a protective shell around the winding. Next, I'd like to introduce Michael here, who can explain some of the important steps in the core stacking process itself.
How are you doing? I'm a production technician here at Mitsubishi. I work solely with the core steel on a daily basis. Like you said, we receive the coil group, it gets inserted in a vertical orientation. Our job is to stack steel around it all day, every day. So like you said, you have steel on every surface of this coil group. And we have to maintain a gap here. It's customer specific, but the majority of the time our customer wants a 40 millimeter gap, and it's our job to maintain that gap. All right, so after the coil group has been inserted, it's our job to put the steel around the coil group. The longer steel is what we call leg core. It's going to be inserted by machine, which has been previously filmed. Then the yoke steel will be inserted by hand. And with this particular unit, it's a three-phase unit. There are hundreds of thousands of sheets of steel in this particular unit. We have to maintain a 2 millimeter joint gap from the yoke core to the leg core. So this section right here will be jointed to this section, and our tolerance is a 0 millimeter gap to a 2 millimeter gap, and our job is to specifically maintain that tolerance from the bottom to the top. After the steel has been completed, we will drive a wedge in between the remaining space of the coil group and the top of the steel to kind of pressurize all that steel down so there's no movement during transportation as well as during operation. And from there on, the upper tank will be put on, and it'll be sent on to the next department for welding and external pieces to be put on.
The main reason we use so many sheets of steel when stacking the core is basically to improve the efficiency of the transformer in operation. The thinner sheets are actually individually insulated from each other with a very thin film. And this insulation allows for low heating of the core steel in the magnetic field, which reduces the operating temperatures and minimizes the stray losses of the transformer in service, thereby improving the efficiency of the transformer.